Good morning, students. In the last class, we discussed about the Ampere Circuit law. Right? By using those laws, we discussed about the applications of Ampere Circuit law. That is, one is solenoid, and another one is toroid. So these two are the instruments or equipment. By this, we can produce the magnetic field. Right? So by using the Ampere Circuit law, we are going to find the magnetic field in solenoid and toroid, right? So let's discuss one by one. So start from the solenoid. So what is solenoid? So solenoid is an instrument that produces the magnetic field, right? So how we construct the solenoid, right? So an insulated copper wire is closely wound or wind in helical shape. So copper wire, insulated copper wire na yav ತರ wind ಮಾಡಿರ್ತೀವಿ ಅಂದ್ರೆ helical shape ಅಲ್ಲಿ wind ಮಾಡಿರ್ತೀವಿ, and its radius is negligible compared to its length. So what is the purpose of solenoid? Means it is used to produce magnetic field. So magnetic field produce ಮಾಡೋದಕ್ಕೆ ನಾವು solenoid ನ ಯೂಸ್ ಮಾಡ್ತಿದ್ವಿ. So solenoid ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ in televisions ಅಲ್ಲಿ ನಾವು magnetic field produce ಮಾಡೋದಕ್ಕೆ solenoid ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, right? So how we construct means insulated copper wire is wound in the helical shape. So helical shape ಅಲ್ಲಿ ನಾವು last class ಕೂಡ discuss ಮಾಡಿದ್ವಿ. When a charge enters to the magnetic field, it traces the helical path. That means when it other than 90 degrees. So charge moving with some velocity, when it enters the magnetic field other than 90 degrees, then it traces the helical path. So same shape ಅಲ್ಲಿ ಏನಿರುತ್ತೆ ನಮಗೆ, that is helical shape ಅಲ್ಲಿ wound ಮಾಡಿರ್ತೀವಿ. So ಅಂತದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, solenoid ಅಂತ ಕರಿತೀವಿ, right? So this is the helical shape, right? So its radius of the solenoid is negligible compared to its length. That means the radius ಏನಿರುತ್ತೆ ನಮಗೆ ಈ solenoid ದು ಕಮ್ಮಿ ಇರುತ್ತೆ. ಯಾವುದು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ length ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ, that means length of the solenoid is more. So ideal solenoid ಅಂತ ಕರೀತೀವಿ. That means it is very length. So ನಾವು helical shape ನ ತುಂಬಾ length ಅಲ್ಲಿ ನಾವು ಅದನ್ನ ತಗೊಂಡ್ರೆ ಅದನ್ನ ನಾವು ಏನಂತ ಕರೀತೀವಿ, ideal solenoid ಅಂತಾನು ಕರೀತೀವಿ. So as this is the conductor, so copper wire ಅಂದ್ರೆ again this is the conductor. So current is flowing in the conductor, right? So current direction ಅಲ್ಲಿ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ. So current ಈ ಕಡೆಯಿಂದ ಹೋಗ್ಬಿಟ್ಟು we get, so one side ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂಡ್ರೆ, so this is the direction of the current, right? So ಹೋಗ್ತಾ ಈ ತರ ಹೋಗುತ್ತೆ. So that is inside the board. So ಇಲ್ಲಿ ಹೊರಗಡೆ ಬರ್ತಾ ಇರೋದು from outside the board. So initially ಹೇಳಿದಂಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು plane of paper ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, so inside the board current ಹೋಗ್ತಾ ಇದೆ ಅಥವಾ plane of the paper ಒಳಗಡೆ current ಹೋಗ್ತಾ ಇದೆ ಅಂದ್ರೆ, so that we denoted with the cross symbol. So either it may be current or it may be magnetic field. ಎರಡಕ್ಕೂ ಕೂಡ ನಾವು represent ಮಾಡ್ತಾ ಇರೋದು circle with the cross. So the same current will coming out of the plane of the paper or plane of the board. So board ಒಳಗಡೆಯಿಂದ current ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ, so that is denoted with the circle with the dot. So ಇದು ಇಲ್ಲಿ ನಮಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, right? So ಇಲ್ಲಿ current ಏನಾಗ್ತಿದೆ, it is going inside the board. So ಇಲ್ಲಿ ತಗೊಂಡ್ತಾ ಇರೋ current that is coming outside the board, right? So by using the right hand rule, so if we hold the solenoid, so in the right hand, so right hand ಅಲ್ಲಿ ಈ solenoid ನ ಈ ತರ fold ಮಾಡಿದ್ರೆ, so fingers representing the direction of current. So direction ಏನಾಗ್ತಿದೆ, current ಈ ತರ ಬರ್ತಾ ಇದೆ. So magnetic field ಯಾವ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ, towards the right side, right? So magnetic field ಯಾವ ತರ ಹೋಗುತ್ತೆ ಅಂದ್ರೆ, so like this, gives the direction of the magnetic field. So this is magnetic field B. So solenoid inside ಅಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ magnetic field ಇರುತ್ತೆ. So that is the direction is given by the right hand rule. So right hand ಅಲ್ಲಿ ನಾವು solenoid ನ hold ಮಾಡಿದ್ರೆ so remaining fingers representing the direction of the current in the solenoid and the extended thumb gives the direction of the magnetic field, right? So now here we are going to find the magnetic field in the solenoid. So that means the value of B. So ಇದನ್ನ ನಾವು cross sectional area ದಲ್ಲಿ ಕಟ್ ಮಾಡಿದ್ರೆ so we get this like this. Right. So ಇಲ್ಲಿ ನಮಗೆ current direction ಇಲ್ಲಿ ಬರ್ತಾ ಇರೋದು coming out of the board. So coming out of the board ಇರೋ ಕಡೆಗೆಲ್ಲ ನಾವು ಏನು ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ ಡಾಟ್ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. So this is the upper part. So ಇಲ್ಲಿ ಬಂದ ತಕ್ಷಣ ನೆಕ್ಸ್ಟ್ ಏನಾಗ್ತಿದೆ it is going inside the board. So going inside the board ಇರೋ so bottom part ಅಲ್ಲಿ ಇರೋದನ್ನು cross symbol ನ represent ಮಾಡ್ಕೊಳ್ತೇವೆ. It indicates what the direction of the current. So top most layer ಅಲ್ಲಿ that means ಇದನ್ನ cross sectional area ದಲ್ಲಿ ನಾವು ಕಟ್ ಮಾಡಿದ್ರೆ so this gives what the cross sectional representation of the solenoid. So solenoid na exactly middle ಅಲ್ಲಿ halfway cut ಮಾಡಿದ್ರೆ we get like this. So this gives what the wiring wire na wind ಮಾಡಿರೋದು ಈ ತರ represent ಇರುತ್ತೆ. So ಇಲ್ಲಿ current na represent ಮಾಡ್ಕೊಳ್ಳೋದನ್ನ ನಾವು ಈ ತರ represent ಮಾಡ್ಕೊಂತೀವಿ. That is current which is coming out of the board from the top and again it is going inside the board. So ಇದು current ಹೊರಗಡೆ ಬರ್ತಾ ಇದೆ. So ಇಲ್ಲಿ ಮತ್ತೆ current ಒಳಗಡೆ ಹೋಗ್ತಿದೆ. ಈ wire ಅಲ್ಲಿ ಮತ್ತೆ ಹೊರಗಡೆ ಬಂದು ಇಲ್ಲಿ ಒಳಗಡೆ ಹೋಗುತ್ತೆ. So that gives what the helical shape, right? So again inside we have the magnetic field. So this gives what the magnetic field. So ಎರಡು diagram same ಇದೆ. ಇದು general representation. So ಇದು cross sectional representation. Cross sectional representation ಅಂದ್ರೆ solenoid ನ exactly half ಗೆ ಕಟ್ ಮಾಡಿದಾಗ ಈ ತರ ಕಾಣಿಸ್ತಾ ಇರುತ್ತೆ. So this gives what the representation of the current direction, right? So this is the current direction which is coming outside the board and cross symbol indicates again going inside the board, right? So now by using Ampere circuit law. So by using Ampere circuit law, we are going to find the magnetic field B. So Ampere circuit law is the line integral of the magnetic field over the length dl that is equals to mu naught times the total current. So that is the current which is enclosed in the surface. So our surface imaginary surface. So on the surface na ನಾವು ಏನಂತ ಕರ್ಕೊಂಡ್ವಿ Ampere surface ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು. So ನಾವು ಇವಾಗ value of B ನ find out ಮಾಡಬೇಕಂದ್ರೆ by using Ampere circuit law first we need to take one Ampere's loop. That means Ampere's loop. So last we taken that one as circular shape. So now I am going to take one rectangular loop. So ಈ law use ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ according to this law we need to take one Amperean loop. So this gives what Amperean loop. So loop के name ಕೊಡೋದಾದ್ರೆ A B C D, right? So direction of the loop ಈ ತರ ಇದೆ, right? So that means half. So in loop ಅಲ್ಲಿ half magnetic field present ಆಗಿದೆ, in half magnetic field ಇಂದ ಹೊರಗಡೆ ಇದೆ, right? So 2 points ಅಂತ consider ಮಾಡ್ಕೊಂಡ್ರೆ one is point P and another one is point Q. At point P the magnetic strength is more and the magnetic field is uniform. So at Q, so the magnetic strength is weak and we can say that the magnetic field at Q point is almost zero because ಇಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರಹದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇಲ್ಲ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ is only produced inside the solenoid, hence the magnetic field outside the solenoid is zero. So we can say that at P magnetic field, so magnetic field we can represent by B. So magnetic field is strong and uniform. So uniform means parallel agide elladunu magnetic field. Then at Q magnetic field is weak and almost zero. So ಎರಡರಲ್ಲಿ ಯಾವುದು ಬೇಕಾದರೂ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So weak ಇದೆ ಅಥವಾ it is almost zero, right? So now applying to the relation. So this gives what the integral. Integral means summation. So now last problem alli consider ಮಾಡಿದಾಗ directly we take on the circle, that is circumference of the circle. We direct 2 pi r ಅಂತ ತಗೊಂಡ್ವಿ, but here it gives the rectangular shape. So we can take directly the area of the rectangle or we can take individual. So ಇದು complete Ampere loop inside ತಗೊಂಡಿದ್ರೆ we can directly 7 8 ಇದೆ, but Ampere loop ಅಲ್ಲಿ flow of the current is 1 2 3 4, right? So that we represented by IE, right? So this is the dot product. So ನೀವು ವೆಕ್ಟರ್ ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿದಿರಾ, the dot product between two, that is A dot B dot product. If you expand that one, magnitude of A into magnitude of B into cos theta. So this gives what the definition of the dot product. So in place of A we have the magnetic field, in place of B we have dl, right? So we can write this one as B dl cos theta, right? So that means theta is the angle between the magnetic field and the current element, right? So in the first case, so this is the first case. So in first case, current element is along horizontal and the magnetic field is along horizontal. That means both are parallel. That means theta value is how much? So theta is 0 degree, right? So cos 0 is 1. So we getting the maximum B dl, right? So we can write that one A to B B dl, right? So ಇಲ್ಲಿ vectors ಇದೆ. So vectors na remove ಮಾಡಿದ್ರೆ we can directly write the magnitude B dl cos theta. So theta value is 0. Theta is the angle between magnetic field and the current element. So both are parallel, hence theta is 0. So we get only the magnitude, that is B into dl. We need to integrate the dl, right? So from B to C, right? Now cases. So again by the same relation, magnetic field into current element, we have the formula B dl cos theta. So this is in the case of second case, the limit starts from B to C. That means this is the current element, right? So this current element is perpendicular to the magnetic field. So that means the angle between the B and C current element to the magnetic field is 90 degree, right? So second case alli angle estirutte 90 irutte, right? So cos 90 is 0. So 0 into B dl is 0, right? So this whole term we can write that one as 0, right? Plus and the next term. So this is outside the field, that is outside the solenoid. So outside the solenoid there is no magnetic field. That means B value is 0. So 0 into dl is 0. So we can write this one is also 0, right? And again last one B dl, right? So B dl is again B into dl cos theta. The line element is dA and that is perpendicular to the magnetic field. That means angle between the line element and to the magnetic field is 90 degree, right? So this 90 degree. So again cos 90 is 0. So 0 into B dl is 0, right? So in the last also we get 0, that is equals to mu naught IE. So we can take this one as length L. So Ampere and loop length na ನಾವು L ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೋಬಹುದು. L x ಏನ್ ಬೇಕಾದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ ಅದನ್ನ, ರೈಟ್? ಅಥವಾ ಇಲ್ಲಿ x ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಅಥವಾ L as your choice, right? So ಇಲ್ಲಿ number of turns ಇದೆ, only one turn ಇಲ್ಲ ನಮಗೆ. So here we have the number of turns, right? So where n is the, we calling this one as first equation, right? So n is the number of turns per unit length. So we can take n number of turns. So ಇಲ್ಲಿ ನಮಗೆ 8 number of turns ಇತ್ತು ಅಂದ್ರೆ 8 per unit length. That means value of n ಎಷ್ಟಿರುತ್ತೆ, 8 ಇರುತ್ತೆ. So 10 turns ಇತ್ತು ಅಂದ್ರೆ 10. So each one circle represents one turn, right? So that means total number of turns, that is equals to n into l, right? So ಇದು ಎಲ್ಲಷ್ಟು ಲೆಂತ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ, so ಈ ಲೆಂತ್ ಅಲ್ಲಿ ಎಷ್ಟು ಟರ್ನ್ಸ್ ಇರುತ್ತೆ ಅಂದ್ರೆ, so that is represented by n into l. So 1 meter ಲೆಂತ್ ಅಲ್ಲಿ 8 ಟರ್ನ್ಸ್ ಇತ್ತು ಅಂದ್ರೆ, so number of turns ಎಷ್ಟಿರುತ್ತೆ, 8 ಇರುತ್ತೆ, right? So 2 meter ಲೆಂತ್ ಅಲ್ಲಿ 8 ಟರ್ನ್ಸ್ ಇತ್ತು ಅಂದ್ರೆ, that means number of turns ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ 16 ಇರುತ್ತೆ, right? So ಇದು number of turns ಆಯ್ತು. So current flow ಆಗ್ತಾ ಇದೆ out of all these turns. So ಎಲ್ಲ turns ಅಲ್ಲೂ ಕೂಡ current flow ಆಗ್ತಾ ಇರೋದ್ರಿಂದ, so we can take initially here we need to find the value of IE, right? So current flowing in the solenoid, I, that is equals to I into NH. So I is only for this amount. So total current into NH. So total current ಎಷ್ಟು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ, so ಈ ಟರ್ನ್ಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ನಾವು ಬರ್ಕೊಳ್ಳೋದು I into N. So L is there, right? So N L, right? So take on this one as second equation, right? So substitute 2 in 1. So only we have this A to B, B to L, that is equals to mu naught. So in place of I, we can IE, we can write I into N L, right? So B is constant, we can take outside. So integration of dl is L. So L is limit from A to B, right? So L ಅಂದ್ರೆ length ಎಷ್ಟಿದೆ ನಮಗೆ A ಇಂದ B ಇದೆ. So that is equals to C to D. So directly we can write this one, integration of dl, we can write that one as L, right? That is equals to mu naught I L. So L get cancelled. So the magnetic field B is equals to mu naught I N or mu naught Ni. So solenoid ಅಲ್ಲಿ magnetic field ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ, this is the relation, right? So 3 marks ಗೆ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಇರುತ್ತೆ ಈ ಸಲ. So explanation ಅಲ್ಲಿ you can take this relation. So ಈ diagram ಬರಿದಲೇ ಇದ್ರು ಕೂಡ, so this is very important and direction is also very important, right? So we need to start with the condition by using Ampere Circuit law, because these are the applications of the Ampere Circuit law. So by using Ampere Circuit law, we are going to find the magnetic field inside the solenoid, right? So this gives only the magnitude of the magnetic field, and the direction of the magnetic field is given by the right hand rule. So right hand alli ನಾವು ಈ solenoid na hold ಮಾಡಿದ್ರೆ, it fingers represents the direction of the current, then thumb represents the direction of the magnetic field, right? So the magnetic field depends on what factors, means the magnetic field depends on the number of turns. So solenoid ಅಲ್ಲಿ number of turns ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಯಿತು ಅಂದ್ರೆ magnetic field ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. And the second one is current. So solenoid ಅಲ್ಲಿ current value ನ increase ಮಾಡಿದ್ರೆ magnetic field value ಕೂಡ ಏನಾಗುತ್ತೆ, increase ಆಗುತ್ತೆ, right? So on what factors the magnetic field in the solenoid depends on two factors. One is the number of turns n. So n increase ಆದರೆ magnetic field increase ಆಗುತ್ತೆ, n decrease ಆದರೆ magnetic field decrease ಆಗುತ್ತೆ. So next current increase ಆದರೆ magnetic field increase ಆಗುತ್ತೆ, current decrease ಆದರೆ magnetic field decrease ಆಗುತ್ತೆ, right? So this is about the solenoid, and this one is the final relation, right? ಸೊ ಇದಕ್ಕೆ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಇಲ್ಲದೆ ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಇಷ್ಟು ಟರ್ಮ್ಸ್ ನ 0 ಅಂತ ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡ್ಕೋಬಹುದು, ರೈಟ್. ಸೊ ಬೈ ಯೂಸಿಂಗ್ ದ ರಿಲೇಷನ್ BDL cos, ಸೊ ಇಲ್ಲಿ cos 90 ಇರುತ್ತೆ, ಅಗೇನ್ ಇಲ್ಲಿ cos 90 ಇರುತ್ತೆ, ಲೈನ್ ಎಲಿಮೆಂಟ್ಸ್ ಮತ್ತೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಇರೋದ್ರಿಂದ ಸೊ ದೀಸ್ ಟು ಟರ್ಮ್ಸ್ ಬಿಕಮ್ 0. ಇಲ್ಲಿ ಏನು 0 ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ಔಟ್ಸೈಡ್ ದ ಫೀಲ್ಡ್. ಸೊ ಈ ಲೈನ್ ಎಲಿಮೆಂಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಂದ ಹೊರಗಿದೆ, ಸೊ ಯಾವುದೇ ತರದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇಲ್ಲ. ಸೊ ದಟ್ಸ್ ವೈ B value 0 ಆಗುತ್ತೆ. ಸೊ 0 into anything is 0. So that's why we can take that one as 0, right? So 3 to 4 steps ಬರುತ್ತೆ, ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. So next is toroid. So toroid is similar to that of the solenoid. So solenoid ಏನಿತ್ತು ನಮಗೆ ಸ್ಟ್ರೈಟ್ ಇತ್ತು. ಸೊ toroid ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಅದನ್ನ ಬೆಂಡ್ ಮಾಡಿದ್ರೆ ನಮ್ಗೆ ಯಾವ ಶೇಪ್ ಬರುತ್ತೆ, ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್ ಬರುತ್ತೆ. ಸೊ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, toroid. So toroid is a hollow circular ring wounded by the insulated wire ಸೊ solenoid ಮತ್ತೆ toroid ಎರಡು ಸೇಮ್ ಇರುತ್ತೆ. ಸೊ toroid ಅಂದ್ರೆ ಏನಂದ್ರೆ ಇಟ್ ಇಸ್ ಎ hollow circular ring which is wounded by an insulated wire or any copper wire very closely, right? So that means first we need to consider one hollow circular ring. So hollow means ಅದರ ಒಳಗಡೆ ಏನು ಇರೋದಿಲ್ಲ ಅಂತ, almost circle here, right? So this circular ring is wounded by a wire. So wire ಇಂದ ಇದನ್ನ ಏನು ಮಾಡ್ತೀವಿ, wound ಮಾಡ್ತೀವಿ. So first ಏನು ಮಾಡ್ತೀವಿ, ಒಂದು ಕನ್ಸಿಡರಿಂಗ್ ಒಂದು ಹ್ಯಾಲೋ ಸರ್ಕ್ಯುಲರ್ ರಿಂಗ್. ಸೊ ಈ ಸರ್ಕ್ಯುಲರ್ ರಿಂಗ್ ಮೇಲ್ಗಡೆ ಕಂಪ್ಲೀಟ್ ಆಗಿ ವೈರ್ ನ ಸುತ್ತುತ್ತಿದ್ದೀವಿ, ರೈಟ್? ಸೊ ದಟ್ ಮೀನ್ಸ್ ಕ್ಲೋಸ್ಲಿ ಪ್ಯಾಕ್ಡ್ ವೈರ್ಸ್ ವಿಚ್ ಆರ್ ಮೂವಿಂಗ್ ಆನ್ ದ ಸರ್ಕ್ಯುಲರ್ ರಿಂಗ್. ಸೊ ಈ ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್ ಗೆ ಕರೆಂಟ್ ನ ನಾವು ಫ್ಲೋ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ರೈಟ್? ಸೊ ಕರೆಂಟ್ ಇಸ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ಅಗೈನ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್. So here also we are going to find the magnetic field. So where I is the current which is flowing in the circular in a toroid. So current ಏನಾಗ್ತಾ ಇದೆ, flow ಆಗ್ತಾ ಇದೆ. So now we need to cut this toroid. So exactly half ಅಲ್ಲಿ cut ಮಾಡಿದ್ರೆ that we can represent in the cross sectional area. Right. So this one is the circular ring. So now we need to represent the current direction. So initially from outside ಏನಾಗ್ತದೆ current ಹೋಗ್ತಾ ಇದೆ, that means current is going inside, so that means here is current is coming outside, so here the current is going inside. So ಇಲ್ಲಿ ನಮಗೆ ಏನಿರುತ್ತೆ current which is coming outside. Inside dot okay. ಕರೆಂಟ್ ನ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ತಗೊಂಡಿರ್ತೀರೋ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ನೀವು ಇನ್ಸೈಡ್ ಆದ್ರೂ ತಗೋಬಹುದು, ಔಟ್ಸೈಡ್ ಆದ್ರೂ ತಗೋಬಹುದು. So here also by using Ampere's circuit law, right? So idu kuda application of the toroid is an application of the Ampere circuit law irodrinda. So here also we are going to find the magnetic field by using the Ampere circuit law. So here we are going to take 3 Ampere loops. So one is inside. So this one is the first Ampere loop. So we call that one as first loop, and so in between the halo ring we taken the another Ampere loop, that one we taken as second ring, and the last is completely outside, so this we taken as third Ampere loop, right? So considering 3 Ampere loops, calling 1, 2 and 3, right? So 3 Ampere loops ತಗೊಂತಾ ಇದೀವಿ. So each having the radius from the center of a circular ring. So for first loop the radius is r1, and for the second loop the radius is r2, and for the third we taken radius is r3. So 3 loop consider ಮಾಡಿದೀವಿ, 3 having different radius from the center. So ಈ center ಇಂದ ನಾವು 3 ತಗೊಂತಾ ಇದೀವಿ. One is inside the halo ring, and in between the halo ring, and completely outside the halo ring, right? So 3 Ampere loops na consider ಮಾಡಿ. So first we need to find the magnetic field inside the halo ring, right? So that means applying Ampere's circuit law for first Ampere loop. So first loop ಗೆ ನಾವು Ampere circuit law ಅನ್ನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. So Ampere circuit law states that the line integral of magnetic field into line element, that is current element, that is equals to mu naught times the current IE. So ಈ ಸರ್ಕ್ಯುಲರ್ ಲೂಪ್ ಅಲ್ಲಿ ಎಷ್ಟು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋದನ್ನ ಹೇಳುತ್ತೆ, right? So magnetic field in an closed surface. So this is the Ampere loop or Ampere surface. So this is the imaginary surface. So ಈ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ಎಷ್ಟು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ ಅಂತ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡೋದಕ್ಕೆ Ampere circuit law ಇರೋದು, right? So BDL is equals to mu naught IE. right? So we taken this as a circular surface. So if we add all the current elements, then we get the circumference of the circle, right? So keeping magnetic field outside. So if we take a circumference of a circle, that means integration of dl we can take 2 pi r1. So r1 is the radius of the circle, right? So that is equals to mu naught into IE. IE is the total current which is enclosed in the surface. So ಈ ಸರ್ಫೇಸ್ ಅಲ್ಲಿ ನಮಗೆ ಯಾವುದೇ ತರದ್ದು ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇಲ್ಲ, ದಟ್ ಮೀನ್ಸ್ ಯಾವುದೇ ಕರೆಂಟ್ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ. ಸೊ ಯಾವುದೇ ಕರೆಂಟ್ ಎಲಿಮೆಂಟ್ ಇಲ್ಲ ಅಂದ್ರೆ the current is zero in the surface, that means mu naught into 0. So mu naught into 0 is 0. So 0 divided by 2 pi r1 is 0. So hence magnetic field B1 that is equals to 0. So we can take this one as 1. So B1 is the magnetic field which is inside. So here the magnetic field is 0, right? So next, applying Ampere's circuit law for second loop. So next, Ampere circuit law ಯಾವುದು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೀವಿ? Second loop. So second loop again by using the relation. So line integral of B2 dl that is equals to mu naught IE. IE is the current which is enclosed in the circular surface. So ಈ surface ಅಲ್ಲಿ ಎಷ್ಟು current ಇದೆ ಅನ್ನೋದನ್ನ represent ಮಾಡೋದು ನಮಗೆ IE, right? So here taken B2 outside. So dl, integration of dl is the circular path circumference. So we can write that one as 2 pi r2. Right? So circular path radius ಎಷ್ಟಿದೆ? r2 ಇದೆ. So integration of dl ಏನು ಬರ್ಕೋಬಹುದು ನಾವು? 2 pi r2 ಅಂತ ಬರ್ಕೋಬಹುದು, right? So that is equals to mu naught. I is the current which is flowing in the, so ಇಲ್ಲಿ ನಮಗೆ current flow ಆಗ್ತಾ ಇದೆ, right? So this represents the current which is flowing in the toroid, right? So that we can represent in the last solenoid also we taken I is equals to n I. So there we taken length. So here we have taken the circumference of a circle 2 pi r, right? So in circular path, so in current element ಎಲ್ಲೋದು ಕೂಡ circular path ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ so length ಬದಲು ನಾವು ಯಾವ ತಗೊಳ್ತಾ ಇದೀವಿ? Circular path circumference ತಗೊಳ್ತಾ ಇದೀವಿ, right? So that is also r2. So in the RHS and LHS 2 pi r2 get cancelled. So magnetic field V2 is equals to mu naught Ni. Right? So that means magnetic field inside the halo ring. So in between space ಅಲ್ಲಿ ನಮಗೆ ಏನು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ magnetic field ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತದೆ. So this is what that is V2, right? So on the last loop, so applying Ampere circuit law for the third loop, third Amperean loop. So that means for this loop, right? So again here B3 dl that is equals to mu naught IE. So B3 integration of dl. So we can write that one as 2 pi r3, right? So that is equals to mu naught IE. IE is the current. So here it represents the current entering into the circuit, and it is the current which is entering into the circuit, which is the current coming outside the circuit. So ಇದು current ಹೊರಗಡೆ ಹೋಗ್ತಿದೆ, ಇದು ಒಳಗಡೆ ಹೋಗ್ತದೆ. So ಎರಡು ಕೂಡ equal proportional ಇರೋದ್ರಿಂದ one is going inside and another one is coming outside. So ಎರಡು parallel ಇರೋದ್ರಿಂದ so ಇಲ್ಲಿ current elements ಎರಡು inside the circular loop ಏನಾಗುತ್ತೆ? Cancel ಆಗುತ್ತೆ. For example, 2 amperes is current going inside the loop means 2 amperes is current which is coming outside the loop. So 2 ampere ಎರಡು opposite direction ಇರೋದ್ರಿಂದ ಎರಡು ಏನಾಗುತ್ತೆ ನಮಗೆ cancel ಆಗುತ್ತೆ. So the net current which is enclosed in the circular loop again it becomes 0, right? So 0 into mu naught 0. So 0 divided by 2 pi r3 is 0. So B3 is again equals to 0, right? So net magnetic field in a toroid that is equals to V1 plus B2 plus B3, right? So that is equals to 0 plus mu naught Ni plus again 0. So total magnetic field is equals to mu naught Ni, that is B, right? So ಎರಡರದ್ದು ನಮಗೆ ವ್ಯಾಲ್ಯೂ ಏನು ಬರುತ್ತೆ, ಸೇಮ್ ಬರುತ್ತೆ. ಸೊ ಸೊಲನಾಯ್ಡ್ ಮತ್ತೆ ಟೊರಾಯ್ಡ್ ಎರಡರದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಿರುತ್ತೆ, the same relation B is equals to mu naught Ni. So here in two cases we getting 0. So B3 ಅಲ್ಲಿ ಕೂಡ ನಮಗೆ 0 ಬರುತ್ತೆ. That means outside, so this again equals to 0. So outside the toroid kuda 0 irutte. So inside the toroid kuda 0 irutte. So there is a only magnetic field in between the circular ring. So in circular ring alli matra namage magnetic field produce agutte. So this is similar to that of the toroid. So toroid alli kuda namage magnetic field elli produce agtittu andre, so that is in between the circular turns. So in turns middle alli namage magnetic field produce agtittu. So magnetic field outside the toroid is 0. So same wise, solenoid is 0. In the same way, the magnetic field inside and outside the toroid is 0. So it is produces the magnetic field in between the circular ring. So in the left side of magnetic field produce ಮಾಡುತ್ತೆ, and that value is equals to mu naught Ni, right? So ಎರಡು relation same ಇದೆ, but solenoid ಅಲ್ಲಿ only we taken 1 ampere and loop. So ಅಲ್ಲಿ ಏನು ನಾವು rectangle ತಗೊಂಡಿದ್ವಿ ಅಂದ್ರೆ ಇದನ್ನ cross sectional area ಗೆ ಕಟ್ ಮಾಡಿದ್ರೆ it is in the form of the rectangle. So ಇದು rectangular shape ಅಲ್ಲಿ ಇತ್ತು, so that's why we taken rectangular loop. So ಇಲ್ಲಿ ನಾವು circular loop ಏನು ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ವಿ ಅಂದ್ರೆ ಇದನ್ನ cross sectional area ಗೆ ಕಟ್ ಮಾಡಿದ್ರೆ so ನಮಗೆ all this we are getting in the circular shape, hence we taken Ampere loop as circular, right? So ಈ ಎರಡು ತುಂಬಾ important for 3 marks, right? So remaining topic we will discuss in our next class. Thank you.